Today I'm going to show you how to draw a Lewis structure. So first let's go over the steps. The first thing you want to do is find the total number of valence electrons. Then step 2 is to decide on the central atom and draw the bonds. Next, you assign any leftover electron to the terminal or the atoms on the end to form octets. If necessary, and if you have leftover electrons, you'll assign those to the central atom. If the central atom has 8 or more electrons, then generally you're done. If not, then you need to move on to step 5 to create double and triple bonds. And then lastly, you can check the formal charge to see if you have the preferred structure. So let's do an example. We'll use NO3 as our sample. So the first thing we need to do, step 1, was to find the total number of valence electrons. So in this case, we have nitrogen, we have oxygen, and then we have the negative charge. So nitrogen has 5 valence electrons, oxygen has 6, and there's 3 of them, so it'll be 3 times 6. And then for the negative charge, we're going to add 1 additional electron. So that brings the total number of valence electrons to 24. Now, a couple of tips. First of all, you can use the periodic table and use the group number to help determine the number of valence electrons. So generally, group 1A is going to have 1 valence electron, group 2A will have 2, and so on and so forth. Also, for a negative or positive charge, you're going to add 1 for each negative charge, or subtract 1 for each positive charge. So our next step, if we refer back, step 2, is to decide on the central atom and draw the bonds. Now the central atom is always going to be the least electronegative atom in our compound, and it will be the furthest one away from fluorine if you're looking at a periodic table. So in this case, nitrogen is further away from fluorine than oxygen, or it is less electronegative than oxygen, so nitrogen would be the central atom. So we'll put nitrogen in the middle and then bond it to 3 oxygens. So our next step now is that we're going to assign leftover electrons to the terminal atoms to form octets. So we need to subtract out the number of electrons that we've used in our bonding. So we have 1, 2, 3 bonds, and there's 2 electrons per bond, so we have used 6 of our 24. So we now have 18 electrons remaining to assign to the terminal atoms. So we'll just go ahead and fill these. Okay, so now each oxygen has gotten 6 additional electrons to make a full octet. So 6 times 3 is 18. We have now used up all of our electrons. However, we're not done because nitrogen does not have a full octet. So we don't have any extras to assign to it. So we need to create double or triple bonds to fill nitrogen's octet. So what we can do here is we can remove 2 from this oxygen and create a double bond. So that will make all of our atoms have a full 8 electrons in their outer shell. A few things to note here. There are some exceptions to the octet rules. Generally, beryllium, boron, and aluminum will accept less than 8 in their outer shell. Also, if you have an odd number of electrons, or if your atom is in row 3 or lower of the periodic table, then you may wind up with more than 8. So in this case, this is our structure. We can check that by checking the formal charge on each atom to make sure that this is a good structure. So for nitrogen, it had 5 to start with, and it has now 1, 2, 2, 3, 4, because each bond counts as one electron. So 5 minus 4 means that we have a charge of 1 on our nitrogen. The top oxygen, which gave up a pair to the double bond, has 1, 2, 3, 4, 5, 6. Started with 6, so it has a charge of 0. And then our bottom oxygens, again, oxygen started with 6. It has 6 electrons around and 1 bond, so a total of 7. So that has a charge of -1. So this is a good structure because you want the negative charge to be on the more electronegative atom. But we're not quite done. We have to draw a bracket around it because this is a negative atom. Put a negative charge on the entire thing. And also this one is a preferred structure because it is a resonance structure, and that makes it more stable. You could have the double bond here, here, or here. So there's actually 3 different resonance structures for NO3. And that will do it for our Lewis structure.